Now, the ecology study by Cummings et al. Showed that even other fields of study can have a very useful information in helping the epidemiology, predictions and analysis of avian influenza disease itself, and the threats that it carries for future disaster risk management plans, and how it can help on surveillance and control actions. Now, if you have a look below, the first figure below indicates the areas that are most at risk in South Africa to develop AI, and that was as discussed around certain water sources and spots. Now, the second figure below illustrates the environmental risks for avian influenza occurrence in South Africa, and of course within our borders, Lesotho as well, and was based on 7 different environmental variants that were identified at an increasing risk situation. Now, these studies expanded operational field research in the movement of aquatic birds, such as those as the Anatidae or Anseriform families. Now, Sirrod and Gaines introduced this program with an integrated information to better determine the role in the persistence and spread of avian influenza by the ducks. And the ecological studies of Anatidae and other migratory birds, carriers of avian influenza, was included by the work done by these biologists. It assisted in understanding the avian influenza epidemiology better, as well as the relations to the aquatic birds, its host, and the migratory patterns. Now, they used remote sensing and satellite telemetry to do these studies, and at the same time catch these birds and see if they were avian influenza positive or negative in a future if they were caught again. Now, the monitoring included Mali, Zimbabwe, which highlighted for the first time a continual circulation of avian influenza in wild bird populations in the tropical Africa. Now, the role of wild ducks in the transmission of avian influenza virus is still not completely fully understood, but thus it is important for a sentinel system to prevent future outbreaks of avian influenza. Now, in connection with the control, it is very difficult with wild avifauna, if not totally impossible, or even in domestic birds, to control avian influenza. But the ones that one can usually control, some parts of Africa, there are commercial vaccines available, but they need to apply to their state veterinarians or their veterinarians before. But this vaccinations and vaccines are not allowed in South Africa. Now, one can also control it via good biosecurity protocols and exposure the limitation to the breach species. Now, a breach species is a species capable of connecting a population within which the virus persists. For instance, the wild ducks and the ostriches, and a naive population that has never been contacted with the disease that is important to protect, such as the ostriches that was mentioned. Now, in the event of an outbreak, there should be a contingency plan in place and a mobilization of team of expert governmentally enforced to ban trade and increase public awareness and preparedness for the situations of avian influenza. Now, control is a collaborative with the collaborative surveillance programs helps in the event of an outbreak. So the private sector and the general public sector could receive data through a global access information storage system, which will be obtained by sampling of birds and also consist of sharing the data in thus helping to control further outbreaks, and thus also allowing better decision for making control locally and internationally as well as globally. Now, standard control measures to prevent the lateral spread to other farms is done according to an OIE terrestrial animal health code. Now, this basically helps by quarantining of the infected and contact farms, which the birds many of the times cannot get there, rapid culling of the exposed birds or ostriches. The ducks, on the other hand, is a difficult situation because they are the asymptomatic carriers, as was mentioned. And then the proper disposal of these carcasses. And then the ban is in place for 6 months until you've been free of avian influenza regular tests, for 6 months in total. Now, avian influenza seems to be under control, according to the resources here in South Africa, which is the World Health Organization and OIE, and measures are effective. But with the uncertainty of an antigenic drift in the Atenatidae family and other species, one cannot be too cautious at all for testing on a continuous basis. Okay, but monitoring of the host hotspots, such as the dams, the lakes, KwaZulu-Natal, Eastern Cape, as was mentioned, may increase the chances of detection before outbreaks can occur. Now, the impacts on humans are basically, there's a massive loss of life and illness, but avian influenza is not as pathogenic as Ebola, but it has a 60% fatality rate according to the CDC. Now, there are massive socioeconomic impacts, which are direct and indirect, such as farming systems, which those that are farming with poultry or ostriches, ducks or geese. Well, like I said, ducks and geese are not as important here in Africa. And then, of course, the export of the product and ban for the 6 months are part of the indirect effects. Now, it also affects the rural livelihood impacts by the small-scale farmers and the income and the food security thereof. So they lose a lot of income in that area. Now, there's also development of some fear and nostalgia and social interaction affecting during the times of avian influenza. But this might have a good impact on the control aspects, even if it has a negative impact sometimes on the humans. Now, these outbreaks also lead to massive economic loss for the communities and the surrounding farms, and in the international ban of rat-tied products. So the measures for control and ban of the products must be put in place to prevent further spread, but secondary and even heavier tolls on the poultry and ostrich injuries and rural farmers than the direct death of the animals themselves can be actually measured. Now, according to the World Health Organization, since the continent of Africa has major issues with HIV and AIDS, things such as tuberculosis, malaria, and avian influenza can further complicate and even more severely infect situations of avian influenza, and are likely to rise due to the presence of many immune-compromised individuals. Now, according to the World Health Organization, also the risk analysis, there is an estimated 20% of the world population would need massive medical care in the event of a pandemic. Now, that's massive. That's a huge economic loss. That's huge loss of life, work production, and the knock-on effects thereof. So an increased preparedness of public health systems to recognize and deal with these outbreaks is another impact. The people actually start preparing for the situations at the hospitals and are better informed. The public is better informed, and there's an increased communication amongst them at that point. Well, if we look at the impact on the ecosystem or the birds themselves, there's very little on the birds themselves, but the ecosystem has quite a few impacts. Now, the avifauna is most of the times asymptomatic carriers, but the data are still lacking on the species that may be symptomatically affected by the avian influenza. As we've mentioned, H5 and H7 is highly mutagenic and can actually pass on to other species. Now, if we look at a threatened species that may be exposed, or such as those in zoo specimens. Now, on the contrary, that arises with avian influenza in zoos is that the World Health requires culling of all birds infected with the H5N1 or H7 highly pathogenic strains. But federal law in South Africa prohibits the destruction of the birds designated as either threatened or endangered. Now, other issues in modern zoos are pushing for more natural-looking habitats for their animals. This allows zoo birds to have a greater exposure to the flying in of birds and even the anciniform type of birds, because many of the exhibits have water in them that are out in the open or not covered by a gated roof. While these structures may limit the physical contact between the wild and the zoo birds, species still can enter the enclosure and infected birds that are housed inside. Now, the ecosystem services that today families also give, if there is to be decided on a culling situation in the event of an outbreak of avian influenza, would be such as those. Remember, these birds eat a lot of snails, and these snails cause liver fluke and carry a lot of microfilaria types of diseases in South Africa. So that would lead to an increased disease outbreaks in other animals due to their lack of their situation thereof. They also keep in control certain parasites and other parasites that are affecting the plant. Now, ostriches are also affected, like I've mentioned, in the Eastern Cape. But how does it affect our wild ostrich populations? Now, there's a total lack of monitoring, lack of surveillance, and there's even no data available. If it kills the commercial stocks of ostriches so badly, how would it affect the wild stocks? Now, let's take, for instance, St. Lucia, which is a very high lagoon estuary situation where there's a lot of birds, and they also have ostriches in that environment. So in conclusion, with the Anatidae birds and avian influenza, routine avian influenza virus surveillance of aquatic Anatidae or anciniform birds is relatively in its infancy in South Africa. There is a much more collaborative work done in order to fully understand the complex dynamics amongst avian influenza, Anatidae, and other aquatic bird reservoirs, and the ratites, and in the environment of South Africa. South African veterinary infrastructure and resources are stretched over a wide and often remote geological area. Thus, the future for surveillance for avian influenza in South Africa is to work smarter, not harder, and in greater collaboration with other professions. And also continuing with targeting of the central populations of ancioniform species and Anatidae is essential, and hopefully even artificial or biological sensors put in place in the environment that can be monitored remotely. Now, in conclusion also, there's an urgent need to generate an overlaying accurate spatial map system or surveillance programs of the poultry, the ratites, the ancioniforms within a climate or environmental data situation, especially on the agricultural data where these birds overlap with the wild birds. Now, as mentioned, South African migratory ancioniforms and other African aquatic migratory birds has a key characteristic. We do not follow the migratory flight path and do not take annual predictable migration routes as suspected. Thus, it is difficult to predict outbreak patterns and would require further research in spatial patterns, which will assist in minimizing these risk factors for these diseases to be broken out in birds, and then from there on mutate to be able to break out towards humans. Now, these are the references I've used for the avian influenza ancioniform situations. And then you'll see during this discussion, I focused on the ancioniforms, but there are other species of birds. So avian influenza affects a lot of avian species and such. Thank you all for listening, and thank you for the opportunity, Dr. Ayab. If there's any further questions on avian influenza, ancioniforms, and the human situation, please don't hesitate to email me as well. Thank you.